Good day everyone. Today, we are going to present our project entitled the Alon Numeration System, a creative numeration system inspired by Baybayin symbols. Our numeration system is called the Alon numerals, rooted in the Asian traditions of the Luminian tribe, a coastal and river-based community. The Luminian people often traded beads, woven cloth, dried fish, and pottery with merchants from Indonesia and Borneo. Through these exchanges, they saw the writing marks used by traders and began adopting some of the curved and flowing symbols into their own counting system. Around 1100 AD, the Luminian tribe first encountered merchants from Indonesia who introduced them to the idea of recording numbers for trade agreements. At first, they used simple tally marks, but later they adapted and reshaped the foreign symbols into their own script. As trade flourished, the Alon numeration system became a mark of identity. Eventually, the system was used not only for trade, but also in ritual offerings, calendars for planting, and inheritance records. In the Alon numeration system, each symbol was designed with both practicality and cultural meaning. First, the symbol for zero comes from the Baybayin wa. It represents emptiness or an empty space, a reminder that nothingness is also part of creation and beginnings. Next, the symbols for 1 to 4 are shown as small circles. These circles represent pearls, which were important in coastal life, and they also symbolize natural cycles of growth like the seasons and the moon. Finally, the symbol for 5 is a small curve, shaped like a wave. This connects the system to the sea, which was central to the life of the Luminian tribe, both in survival and in trade. So in short, the Alon symbols are not just for counting. They also reflect the environment and values of the community that use them.
And here's our number chart. Here, on the left side, we can see a conversion chart that shows how numbers look in 3 different forms. The first column shows the base 10 numbers, which is our usual counting system. The second column shows the same numbers in base 6, since the Alon numeration system is based on base 6. The third column shows the Alon symbols that we designed, inspired by Baybayin and local cultural elements. For example, the number 5 in base 10 is written as 5 in base 6. And in our system, it is represented by a curve that symbolizes a wave. Another example is 10 in base 10, which becomes 14 in base 6. And you can see how the Alon symbol combines dots and the wave symbol to represent it. This chart serves as a guide to easily compare how a single value is written across different numeration systems. On the left side, you can see the Alon symbols of 3 for hundreds, 0 for tens, and 5 for ones. To convert the base 6 number 305 to base 10, multiply each digit by its corresponding power of 6 and add the results. For the hundreds place, 3 is multiplied by 6 squared, which equals 36, resulting in 3 times 36 equals 108. For the tens place, 0 is multiplied by 6 to the power of 1, resulting in 0. For the ones place, 5 is multiplied by 6 to the power of 0, which equals 1, resulting in 5. Adding these results together, 108 plus 0 plus 5 give us 113. Therefore, the base 10 equivalent of 305 in base 6 is 113. To convert 113 to base 6, we divide 113 by 36, which gives us 3, with a remainder of 5. The 3 represents the 6 squared place. Next, we consider the 6 to the power of 1 place. Since the remainder 5 is less than 6, we place 0 in this position. Lastly, the remainder 5 represents the 6 to the power of 0 place. Therefore, combining this, 113 in base 10 is equals to 305 in base 6.
Now let's try addition using the Alon numeration system. We are adding two numerals, 305 and 120. First, we convert each into base 10 by multiplying them with their place values. For 305, 3 times 36 is equals to 108, 0 times 6 is equals to 0, 5 times 1 is equals to 5. Adding this is equals to 113. For 120, 1 times 36 is equals to 36, 2 times 6 is equals to 12, and 0 times 1 is equals to 0. Adding the 3 up will equal to 48. Now we will add the results. 113 plus 48 is equals to 161 base 10. Now we will need the base 6, so we will convert 161 back into base 6. We divide by place values of 6, wherein 161 divided by 36 is equals to 4, remainder 17. Now 17 divided by 6 is equals to 2, remainder 5. So 161 in base 10 is equals to 425 in base 6. Therefore, the sum of 305 and 120 in the Alon numeration system is 425, or 425. And as you can notice as well, you can add them directly. You can see where in 3 plus 1 is equals to 4, 0 plus 2 is equals to 2, 5 plus 0 is equals to 5. Again, resulting into 425, or 425. Now the practice. So we can see here that the given is 151 or 151 base 6 and 220 or 220 base 6. Sabi nga natin kanina, we can add directly. So let's try. 1 plus 0 is obviously 1. So let's write 1 pearl. Ngayon dito tayo mahihirapan. 5 plus 2 is equals to 7, right? But remember, base 6 tayo. Ang max natin ay 5 or the Alon. Anong mangyayari kapag naging 6 and above na siya? We will graduate or ila-level up natin siya into the 100 tier. Paano natin gagawin yon? We have here 5. We have here 5. Anong sabi ko? Pag naging 6 na siya, ilalagay na natin siya sa hundreds. Eh, naging 7 siya. So, yung 6 lang ang mapapupunta dito sa hundreds. Turning into 1 pearl. Now, itong natitira na to, ay ibabalik natin sa tens. Kasi siya na lang yung natitira doon sa 7. So, we have a pearl in tens. Now, hindi pa yan tapos. Dito naman tayo ngayon sa hundreds tier. 1 plus 2 is equals to 3, right? Pero may dinagdag tayong pearl. So, itatabi lang natin yung 3 dyan. Now, we have 4, 1, 1 as the answer. Again, we can check this by converting it to base 10. So, convert natin. And again, i-add lang natin to lahat. And we will have 67. We will do the same here. Kasi ito yun eh. Dito yun eh. Ga-addin na ulit natin tong tatlo, resulting into 84. Ngayon, itong dalawa naman yung pag-a-addin natin. At ang makukuha natin ay 151. Hala, hindi naman siya 411. Remember, we converted this one into base 10. Ngayon, para malaman natin kung tama talaga yung sagot natin, ibabalik natin si 151 into base 6. Paano nga ulit yon? We will divide in place value of 6. So, 151 divided by 36 is 4. 4 times 36, we will have 144. Minus lang natin yan. We will have 7. Now, is 7 still divisible by 6? Yes. 1 lang. 1. What did we get? 4, 1, 1. 4 for the hundreds, 1 for the tens, and 1 for the ones. Another way of checking, tuturo ko na rin, is by multiplying this sa place value nila to see if 151 ang makukuha natin. Let's try that as well. 36 for 100, 6 for tens, and 1 for ones. 1 for 4, 6, and 1. Adding these 3, we will have 151 as well. Same as this. Now we can say that our answer is correct. The 411 or 411 base 6. Moving on, let's now try subtraction using the Allen numeration system. We now have two numbers, 551 base 6 and 231 base 6. First, just like the addition, we will convert them to base 10. 5 times 36 is equals to 180, 5 times 6 is equals to 30, 1 times 1 is equals to 1. Adding this will equal to 211. Now for the other number, 2 times 36 is equals to 72, 3 times 6 is equals to 18, and 1 times 1 is again 1. Adding these 3 up will give us 91. Now we will subtract the results. 211 minus 91 is equals to 120. Next, we will convert 120 back to base 6. 120 divided by 36 is equals to 3, remainder 12. Now 12 divided by 6 is equals to 2, remainder 0. And just like addition, we can subtract directly. For example, the 5, which is the Alon, can be turned into 5 pearls. After turning it into 5 pearls, we can now deduct 2 pearls. We can do the same on the other 5. But now we will deduct 3 pearls. And on the 1 pearl, we will deduct another 1 pearl, resulting into wa or 0. Now let's practice. We have 551 or 551 base 6 and 502 or 502 base 6. As I've said earlier, kaya din nating isubtract directly itong mga Allen numerals natin. So let us try. Now, 1 minus 2 cannot be, di ba? Kasi mas malaki yung 2. Ngayon, ano gagawin natin? Magbaborrow tayo. Hihiram tayo dito. So, paano? Gagawin natin siyang 5 pearls. Kasi, di ba, 1 Alon is equals to 5 pearls. It represents 5. Ngayon, pag nagborrow tayo dito ng isa, ang kahulugan na niyan ay plus 6. Kasi, again, we are base 6. So, yung hiniram natin na isang pearl dito sa 5 ay magiging 6. So, 6 plus 1 is equals to 7. 7 minus 2 is equals to 5. Ayan. Ngayon, dito naman tayo sa tens. 4. 4 na siya kasi nagkaborrow tayo sa kanya, di ba? 4 minus 0 is equals to 4. So, copy lang natin. Ngayon, 5 minus 5 is equals to 0, di ba? Ano ba ang 0 natin? Wa. But, dahil 0 na siya, hindi na tayo required isulat pa yung wa kapag nasa dun sa taas yung 0. So, ito na yung sagot natin. 4 and 5 or 45. Tapos ngayon, i-check naman natin if tama talaga yung nasagot natin. Paano nga ulit? I-multiply lang natin siya sa place value niya. Just like this. Now we will add this 3. We will get 211. We will do the same here. Adding this 3, we will get 182. And the results, yun ang ating pagmamainasin. And we will have 29. Divide lang natin siya by 6. So, 29. Divisible ba siya ng 36? Hindi. So, papunta na tayo sa tens. Ano ba ang equivalent ng tens? 6. 29 divided by 6 is equals to 4. 4 times 6 is equals to 24. 29 minus 24 is equals to 5. And there you have it. Dahil pansin nyo, hindi siya divisible by 36. So meaning, wala tayong hundreds. Diretso tayo sa tens. 4 is the tens and 5 is the ones. Just like our answer. And to check further kung tama ba, i-multiply din natin siya sa place value again. Adding this up, 29 tenths. Same ba nito? Same. So therefore, we can confidently say that our answer 45 or 45's base 6 is the right answer for this problem.
To multiply in base 6, we first need to understand what the numbers mean in base 10. Let's take 10 in base 6. This represents one group of 6 and 0 ones, which equals 6 in base 10. Next, we have 23 in base 6. This means two groups of 6 plus 3 ones, or 12 plus 3, which equals 15 in base 10. When we multiply 6 by 15, the result is 90. Since we are working in base 6, we then convert 90 back into base 6. To do this, we see how many 36 fit into 90. That gives us 2 with a remainder of 18. Next, we see how many 6's fit into 18, which is 3 and no remainder left. This means 90 is written as 230 in base 6. So the final answer to 10 times 23 in base 6 is 230. For division in base 6, let's use the example 100 divided by 10. First, we convert each number into base 10. The number 100 in base 6 is one group of 36 plus 0 plus 0, which equals to 36. The divisor 10 in base 6 is one group of 6 and 0, which equals 6 in base 10. Now, we divide 36 by 6, which gives 6. To express this answer in base 6, we convert 6 back. Since 6 is equal to one group of 6 and 0 ones, the base 6 representation is 10. Therefore, 100 divided by 10 is equal to 10.
For the calendar, what we did was simply replace the usual numbers with our Alon numeration symbols. The days and days still follow the regular structure that we use today, but instead of Arabic numerals like 1, 2, or 3, we use the Alon symbols for 1, 2, and 3. This shows how our number system can be applied in real-life tools, like tracking date. For the clock, it's the same idea. The numbers from 1 to 12 were replaced with our Alon numeration symbols. The function of the clock didn't change. It still tells time the same way, but the design shows how our number system can also work visually in everyday objects. This makes the Alon system more relatable and easier to imagine in daily use. The most challenging part of designing our system was making sure that the place values were consistent and logical. One clear advantage of our numeration system is that it can represent large number in a more compact way. On the other hand, a disadvantage is that it can be confusing at first, especially when converting symbols to base 10. Another limitation is that our system works more smoothly when multiplying and dividing by tens, which reduces flexibility for certain types of calculation. Through this activity, we learn to be more creative with numbers and to appreciate how different numeration systems can exist beyond what we normally use. It showed us that people throughout history have been innovative in finding unique ways to count, record, and organize numbers.